Here we start our lecture number 11, the continuation of lecture number 10. Some more theorem related to the divisibility. So in the last lecture, we just introduced one theorem of division algorithm and related some important definition according to the number theory. In this particular lecture, we will mention another some theorem and the definition of the common divisor. What is the meaning of common divisor and what is the meaning of the greatest common divisor? So we start our lecture. If A divides B and A divides C, then A should divides Bx plus Cy. If A divides B, A divides C, then it should happen that A should divide Bx plus Cy, where x and y is any integer. Say we can say that 2 divides the application of this theorem. First we use the application of this theorem. 2 divides say 6 and 2 divides say 14. Okay, so if we use this theorem, if you want to find 6 into 3, whatever may be the integer, that doesn't matter, x and y is an any integer, plus say 14 into say it's minus 5, say it's minus 5. So if you want to check that is this number is divisible by 2 or not, in that case you can easily recognize that 6 divisible by 2, 14 is divisible by 2. So the linear combination of 6 and 14, that means here we multiplied with 2 integers, that should be divisible by 2. Nothing to prove and you should not calculate anything regarding this. You should not calculate anything because again we repeat the concept, 2 is a divisor of 6 and 14 is also a divisor. 2 is a divisor of 6 and 2 is also a divisor of 14. Therefore any number which you can product, any integer you can product these two number and add this total resultant should be divisible by 2. That is that's why we use this theorem. Okay, so here we start our proof. Given A is a divisor of B, again A is a divisor of C. Since A is a divisor of B, that means according to the divisibility definition, B should be written as some integer into A, and similarly C should be written as some another integer into A. Okay, if we consider B into X, that means this one Bx plus Cy, just we had with multiplied with y, the resultant becomes K1xa plus K2ya. And if we think that the result is exactly this, since it's happened that this one, so this one becomes, so bx plus cy, that should be k1x plus k2y into a. K1 is an integer, k2 is also an integer, x is an integer, and y is also an integer. This one is the product of two integers, should be an integer. This one, the product of two integers, also should be an integer. So addition of two integers, that should also be a integer. That means the overall result of this should be a integer. Since the result is an integer, so you can say that bx plus cy equals to an integer. If we consider this integer is k into a, which satisfy the definition of divisibility. Exactly for that reason we say that A should divide bx plus cy. A should divide bx plus cy. Here is the line. A should divide bx plus cy. Okay. Next we move to the another very important result for relating to your examination also. If A is a divisor of B and B which is not equals to 0, it should not be happening for equals to 0, because you can easily say that 0 by something is always 0. So if B is a non-zero quantity, then B is non-zero quantity, then mod value of A should be lesser than mod value of A should be lesser than sorry mod value of A mod value of A should be lesser than mod value of B. It's very important why we use the mod value. It's very important. If the B is not equals to 0, if we do not use the mod value, what happens? That should be a very important question. Here we write minus 15. Okay, you can easily recognize why we use this mod. If you do not use this mod, in that case there should be a very wrong idea. This one minus 15. Okay, minus 15 is divisible by 3, so 3 is the divisor of minus 15, but 3 is not lesser than minus 15. But if we recognize this result, the mod value of A should be less or equals to mod value. In that case it should be having, so it's very important. Mod value of 3 should be less or equals to mod value of 15, should be less or equals to mod value of 15. Okay, should be less or equals to mod value of 15. Here should be here you should use this result is should be this result should not be less or equals to, for this particular example this result should be less or equals to, but it may be happen that, because you can easily say that 3 which is divisible by minus 3, in that case equality sign over. Okay, when the number are associative associate it satisfy the associate relation, in that case equality sign should occur. Okay, and that's why we use the mod value. If we do not use the mod value, then your concept should be the wrong concept. And this is your proof. Since it is given that A is a divisor of B, so you can write B equals to some constant into A. You should write B equals to some B equals to some integer into A, where K1 should be belongs to the set of integer. And here it is given that B is not equals to 0. Since B is not equals to 0, then K1 should not be equals to 0, because 0 is equals to something, it should not be happening in the real life problem. It may be happen in the congruence case, but in the case of integer, normal integer multiplication, it should not be happen. So if b not equals to 0, then k should not be equals to 0. Okay, the quotient should not be equals to 0. It's represent k1 represent, in this case, the quotient is not equals to 0. Since the quotient is not equals to 0, that means the value of k1, the modulus value of k1 should be greater than 1. Modulus of k1 should be greater than 1, because k1 is an integer and its value is non-zero. That means its modulus value should be greater than 1. And if we consider the modulus or the absolute value in the both cases, in that case the result right hand side becomes mod k into mod a. Okay, so and which result should be greater equals to mod a, because the value of mod k is greater than 1. Since the value of mod k is greater than 1 and mod a is an integer, therefore product of two integer result should be greater equals to a single integer value. Okay, single if we consider a single number here, in that case we can say that mod b is greater equals to mod a. Exactly for that reason we say that mod b is greater than equals to mod a, and hence your proof is completed. This one, Instead proof is complete. Mod A is lesser equals to mod B, or you can say that mod B is greater equals to mod A. Okay. Next we move to another definition of greatest common divisor, because we have already mentioned that in this particular lecture we will mention in this particular lecture we mention a definition regarding a common divisor. It's a basic idea for you. What is the meaning of common divisor? If you want to find the common means both the cases. Common friend, it's a very important idea regarding your age. Common friend means if we consider Ratul is a common friend of Ram and Sham. In that case, Ratul should be the friend of Ram as well as. So here it's the term use common divisor. That means if we consider a divisor, if we consider a integer which is a divisor of another integer, and this particular integer is also divisor of another one integer. In that case, this fixed integer is known as the common divisor of the two integer. If we consider a particular example, say here we consider a particular example to recognize your concept regarding this is 2 is a divisor of 12, okay, and 2 is a divisor of 16. So 2 is the common divisor of 12 and 16. Okay, exactly for that reason here we use the definition of the common divisor. Here we use the definition of common divisor. If a and b are integer, then an integer d is said to be a common divisor, of a and b if d is a divisor of a as well as d is also a divisor of b. Okay, now we introduce the great idea regarding integer, which is the meaning of greatest common integer. Okay, here we use the definition of the greatest common integer. First we study the greatest common divisor definition. If a and b are two integers, not both zero, that very important, then the greatest common divisor, of a and b, and is denoted by GCD. G for greatest, C for common, D for divisor, is the positive integer. When you take a class in the greatest common divisor in your class, it's very interesting. I am already mentioned that it's a 11, 12 or 9, 10 idea, but still most of the student are all the student gets the wrong answer because they haven't any they have not the proper definition regarding the greatest common divisor. Exactly for that reason here we mention the definition of greatest common divisor. D, if we consider D is your greatest common divisor, that is a positive integer. It's very important. The integer should be a positive integer. The greatest common integer should not be a negative integer. Okay, you always recognize that. D is a divisor of A, D is a divisor of B. It's satisfy the definition of the common divisor. Okay, definition of common divisor. And the next part says if C is an another divisor. Okay, if we consider C is an another divisor, C divides A and C divides B, then C should divide D if D is your greatest common divisor. Okay, and if we consider an example, say 18 and 24, okay, 2 is a divisor of 18, okay, 2 is also a divisor of 24. So 2 should be a common divisor of 18 and 14. But if we use this concept in exactly in that form and that form, 6 is a divisor of 18 and 6 is a divisor of 24. Okay, so 2 is a divisor, 6 is a divisor, but still 2 is again a divisor of 6, but there doesn't exist any other divisor which divides 6. So 6 should be the greatest common divisor. So 6 should be the greatest common divisor. Okay, exactly for that reason here we mention a definition regarding common divisor. Example of common divisor: A is 12 and B is minus 18. So 6 be the answer. 6 be the answer. Here we explain 12. The